Alright, now I'm recording. So 7.6 is an application of standing wave. Okay, so you have learned about standing wave previously about this formula. Okay, standing wave had this formula 2a cos kx sin omega t, and then you learn standing wave, it has node and antinode. Node is the particle which does not vibrate at all. Antinode is the particle that vibrate at the maximum amplitude, 2 amplitude. Maximum amplitude. This one, node doesn't vibrate at all. Got node and antinode. So now we want to learn the application of standing wave. So this application of standing wave is using the standing wave that we have discussed. Got node and antinode. So it is actually formed in the musical instrument. Okay, musical instrument like guitar, violin, organ, pipe, trumpet, clarinet, flute. So all that you can find standing wave. Standing wave. So that's why for now we will encounter the nodes and antinodes. Can see all these are standing wave. All these are standing wave. Application of standing wave. As you can see, got node and antinode. All right. So we have actually I have actually made a video before this. Okay, so in this application of standing wave, we are going to encounter three things. Okay, three things: string, closed pipe, and open pipe. String, closed pipe, and open pipe. Actually, there are only three things, and we need to know the waveform. Okay, how is the wave look like? And then we have mode and harmonic. We have mode, fundamental mode, first overtone, second overtone, third overtone, and so on. And the harmonic number. What's the harmonic? What's the harmonic number for each mode? Okay. So closed pipe and open pipe also have their own mode and harmonic. Harmonic number. And then you also have the equation, the general formula for the string, the closed pipe, and open pipe. Okay. And then talking about the velocity of the wave. Okay, velocity of the wave. So for string, you have the own formula, and then velocity of sound in the air is 343. So we will discuss this later on. Okay, but first we look at the notes lah, the concept of it. So formation of standing wave. Okay, let me just show you. So in general, standing wave are set up in the strings of musical instruments, guitar, violin, when plucked, bowed, or struck. So like you see, when you struck the string, you are applying wave into the string, and then this wave will be reflected at the other end. Will be reflected at the other end. So two identical waves moving in opposite direction, they will superposition and then finally form standing wave on the, let's say, the violin string. Okay, like this person playing the violin, also you are striking the string. Actually applying wave inside the string. Later the wave will be reflected at the fixed end, reflected, and then it will form standing wave inside the string. Okay, so you form standing wave inside the string, and then you can hear very beautiful musical sound. Very beautiful musical sound from the violin, from the guitar, from the harps. And then based on the different length, you can hear different note or different sound. Okay, this one guitar based on different thickness. You see, some string is thin, some string is thick. So let me show you. Let me show you one animation I made. Hold on a second. Let me show you one animation I made. See that? Actually, it's not just this part vibrate lah. Actually, it's the whole, the whole wire. But I just simplify it. Okay. You see there are different. Can you see the different thickness? This one is a thin string. It has shorter amplitude compared to the thicker string. Do you play guitar before?
Yes, sir.
If you are a guitarist, you should know the physics concept behind the guitar. You should actually know. Why do you what do you call that? Fret. Fret. This is the fret, isn't it? You are fretting. Why you are fretting at different places? Why are you fretting at different places? Because you want to play different note, right? Different sound, right? You are making the fret because you are actually applying different in length. You are changing the length of the string. It actually shouldn't just vibrate at this part lah. Actually, it vibrate at until the part you fretting. Yeah, maybe if you fret at this part, then the whole guitar string over here will vibrate with standing wave. So you are hearing musical sound from standing wave actually. Yeah. You know why got music? Why got sound from here? Because things vibrate. Like I'm talking right now. My peti suara, my inside here got the peti suara also vibrate. It vibrate the air particle around it, and now you can listen to my voice through your speaker, right? This thing also vibrate. When the string vibrate, it also vibrate the air particle around it. Yeah, vibrate the air particle around it, and that's why you can hear the musical sound. Okay. All right. So why you can hear different sound? Why you can hear different sound? One thing is because you fret. You fret at different length. So you will hear different. We can say different wavelength. You can hear different wavelength of sound. So you hear different frequency of sound. So you can hear different frequency of sound lah. Yeah, high sound or low sound. Yeah, high note or low note. Yeah. Also, the frequency of sound is affected by thickness of string. If you play guitar, you know very well. There is thick string and very thin string, right? Very thin string. So the thin one give a very high pitch, yeah, very high frequency you see, high frequency means short wavelength. You see, short wavelength. For the thick wire, yes, long wavelength because low frequency. So you hear low sound. Agree with me, the guitarist? Do you agree with me?
Yes, sir.
Yeah.
Yes.
You should. Any of you play violin? Also work around the same way, but they strum the string with a stick lah. Yeah, different. Yeah. So work the same way also. Yeah. Also you're using fretting also. Yeah. So this is the animation I made. Okay, using Adobe Animate. Yeah. Okay. Well, that standing wave you are hearing, and then besides string, we also use air column. Yeah, air column we have two. As I said, for air column we have two. We have closed pipe and open pipe. Closed pipe and open pipe is the structure of the flute, the trumpet, all that. Yeah. So the flute, the trumpet. So we have open pipe and closed pipe. Yeah, open end and closed end. What is mean by open end and closed end? Open end means both ends open. Both ends open. That means both end mean like this one. You see the flute here. Here open. The other end also open. Closed end. I don't have example here. Closed end. Okay. Closed end is one end is closed. So both end opens means open end. If one end is closed, it's closed end. Okay. So now we focus on string. Yeah. First we focus on string. So formation of standing wave in stretched string. Yeah. So when a string of length is stretched between two fixed end is plucked and released. So the wave travel down through fixed end and reflected back. See, when you struck at the middle, so you apply wave inside the string, and this wave will travel down the string, and you know this part is fixed and this part also fixed. So what happened is this string will be reflected back, and these two waves, they are identical wave, and they are moving in opposite direction. That's why when they superposition, it creates a standing wave. Just like just like what we have learned in the formation of standing wave, kan? Like this one, you see that? How is standing wave form? When two waves in opposite direction, they superpose, they form the standing wave. Okay? So this is what happened in the guitar string. You plug at the middle or you plug somewhere here. Okay? You sending wave to both sides. And then they get reflected. From the fixed end, and they superpose because these two waves are identical. And they superpose, they form standing wave. Understand? So the wave and reflection wave interfere according to superposition principle and produce standing wave. So this standing wave, so standing wave, like what the picture shown here. You see that? See, it is a standing wave. This wave is a standing wave, isn't it? This wave doesn't move anywhere. See that? It is this wave doesn't move anywhere. It's stationary wave. Yeah. So you are hearing beautiful sound from this standing wave. Okay? So speed of the wave on the string can be calculated using this formula. Yeah, speed of the wave on the string is, cert. This is what? T, tension in the string. Yeah, tension in the string. And then mu is the mass per unit length of the string. This is guitarists will understand this formula. Yeah, guitarists will understand this formula. Let me. Yeah, what does it mean by this formula? Yeah. So the speed of the wave, it depends on tension in the string. Is it affected by tension in the string? Look at let me. What happened? For a second, okay, never mind. See that? Those who play guitar, if you don't play your guitar for a while, you before you start practicing with your guitar, you normally will tune your guitar, isn't it?
Yes, sir.
Why do you tune your guitar? Do you hear different sound when you tune it to different tension?
Yes.
If you loosen it, you hear lower sound, right? If you tighten the string, you hear higher sound. That's why you tune your guitar, to tune it to the correct note. Correct note. So you tune your guitar. So if you tune your guitar, do you realize that actually you are changing the tension in the string? Yeah, when you're tuning your guitar, meaning you are changing the tension in the string. Okay? And also, just now, another factor is what? Another factor is the mass per unit length of the string. Mass per unit length means the thickness of string lah. If I should actually just write something. Rather, I see. Last time I taught you before, right? You see? See? Tension in the string. So if you make a higher tension, the speed of the wave in the string will increase. So when speed increase, you see this formula? When speed increase, frequency increase. Frequency increase. That means you hear at higher tension, you hear higher frequency sound. So if you make the, if you tune the guitar, you tighten the string, you hear higher frequency. If you loosen it, you hear lower frequency. Another thing is the mu. Mu is the thickness of the string. Yeah, like I show you. I see the the thinner, yeah, the thinner one, less mass. It has less mass per unit length. Less mass per unit length. So it has shorter wavelength. Shorter wavelength means higher frequency. Okay, you know, the thicker mass. It has a bigger diameter. Yeah, more mass per unit length. Then you here have longer wavelength, lower frequency. See that? Thickness. If you have a very thin wire means smaller mu. Smaller mu means smaller mass lah. Smaller mass. Then this speed. Okay, so smaller mu means higher speed of wave in the string. Higher speed of wave. If higher speed of wave, then higher frequency. Okay, so like this one, you hear higher frequency because smaller mu, smaller mass per unit length. Smaller mass per unit length. Understand, class?
Yes, sir.
Understand, sir.
Yeah, so everything is physics. Yeah, everything is physics. All can be explained by physics. Yeah, so you can even know the, you know, now besides knowing physics, you know how to calculate already. You know how to calculate certain value, and you can, if you know physics, you know how to make the different, you know how to make physics, you know how to do different different length of it. You can actually create your own guitar. You can create your own guitar, yeah, but you must have the material lah. Okay, you can create your own guitar, yeah? Or simple musical instrument by using different length or what. Yeah, you can create on your own. Yeah, that's what engineer do. Okay, okay. So for a stretch string, we can set up a standing wave pattern at many frequency. The more loops, the higher the frequency. More loops means what? Like this one lah. You see more loops, right? More loops means higher frequency. Less loop means longer wavelength. Longer wavelength means shorter frequency, lower frequency. More loops means shorter wavelength, higher frequency. Okay. Okay. Enough of that. Okay, I want you just have a glance of this. Have a glance first. Which one do you think has higher frequency? Class, which one do you think has higher frequency? The first one, second one, or third one? Which one has higher frequency?
Third one.
Yeah.
Yes, the third one has higher frequency. Why? Shorter wavelength. Understand? This one has shorter wavelength. Just like this one is just like this thin wire, right? This thin wire is higher frequency. Okay, you are correct. This one is higher frequency because shorter wavelength. This one is very long wavelength. Long wavelength means short. Long wavelength means lower frequency. If you see, this frequency is 3 times the first one. 3 kali ganda. You see that? This one, the frequency is 3 times the fundamental frequency. This one is 2 times the fundamental frequency. This is the first thing I want you to see first. Yeah. So the standing wave form on the string force the surrounding wire to vibrate and produce a sound wave in the air. Just like what I explained just now, right? And that's why you can hear the beautiful music from the guitar or violin. Okay, the string vibrate in the fundamental mode, hence the sound wave produced also in the fundamental tone. So the string vibrate at fundamental mode, so the air particle also vibrate at fundamental mode. It vibrate at the same frequency with the string. The air particle always follow the frequency of string. If the string vibrate at second overtone frequency, at very high frequency, if the string vibrate at high frequency, the air particle also vibrate at high frequency, and our eardrum also vibrate at high frequency, and we can hear the same frequency. Understand? So if something vibrate at very high frequency and air particle also vibrate at a high frequency, your eardrum also vibrate at very high frequency, your eardrum will feel pain. Yeah, you will feel painful. Understand? That's why. Yeah, because everything is vibrating. So somebody shout at high. If somebody shout with high frequency, high pitch, you close your ear because it's too painful. Too painful for the air particle to vibrate your eardrum. You understand or not? You understand or not, class?
Yes, sir.
Okay.
Yes, sir.
So you must understand this physics. Okay. So actually this one, you don't have to worry. It's very simple only. You just actually have to, you know, we have three things actually under this subtopic 7.6. You only have three things: string, closed pipe, and open pipe. If you look at the whole notes, it's basically these three things. This is the string, and then later on we have closed pipe, and then we have the open pipe. I have summarized this into one page. Very simple. Yeah, very simple. You just have to remember the fundamental mode. If you can remember the diagram of the fundamental mode, the rest not a problem for you because you can derive it by yourself. You know, if you look carefully, I want you to look carefully the pattern. You know, when I teach something, I like you to see the whole picture first. And then you will know what you are learning. Okay, you will know what you're learning, and to make things easier. Yeah, that's why my video is a summary video. Yeah, summary video. Okay, I don't like to teach. I like to teach a whole picture first. So if you can see, we are actually dealing with three things: string, closed pipe, and open pipe. You just have to remember the first graph enough. Okay, if like the string, it has two fixed end, and the fixed end cannot vibrate. The fixed end particle cannot vibrate, so it is node. Like you see here, my picture here, you see that? Let's consider, let's say you are fixed at this point. Let's say you are, actually it's not just fixed at this point, it's fixed at the point you fret. Understand? The point you fret, not fixed at this point. But I just show example here. Let's say I just put here fixed at this end and fixed at this end. So you can see when it vibrate, the point where it fixed cannot vibrate. Do you see? This point doesn't vibrate, class? See my logo there, Pax Explain Physics, because this originally made by Mr. Pax. Okay, so you fix the point here, so this point become node, understand? Become node, so it doesn't vibrate. So the other point can vibrate, but the point you fix cannot vibrate. Or you can say the point you fret cannot vibrate because the point you fret become node. Understand? The point you touch the string become node. Understand or not? Node means the particle does not vibrate. Understand, class?
Yes, sir.
Do you play guitar before? If you play guitar, you know you fret. You know what is fret? Fret means you pressing the string at certain length. Why you need different length? Because different length produce different sound, different frequency. So the point you press, it doesn't vibrate, right? The point you press, it become note. The point you press become note. Okay? So this is how the string works. The point you fret become note, and the other end means over here, the other end also become note, yeah, because it's fixed. So for string it has 2 point of note. Because it has 2 fixed end. One point is you fret, the point you fret become note. The other end is fixed already, also become note. So the fundamental mode you can produce is only has one antinote at the center. One antinote at the center. So this is the fundamental mode. The lowest frequency you can hear in the string. The lowest frequency. Understand? The lowest frequency. And then if we go higher, If we go higher, how to go higher? Okay, I want to ask you first. I have taught you how to find, before this, I have taught you how to read the number of wavelength, kan, class?
Yes.
How to know one wavelength? One wavelength is from note to the third note, kan? This is one wavelength. You know why this is one wavelength? Because a whole wave is somewhere like from here until here. Understand? Alamak. So from here until here. Let's say there's one particle here, the other particle will be over here. Understand? And then when it oscillate, this particle will go here. This particle will go here, and then this particle will go to this side. Understand, class? Yeah. This particle at first, at let's say 0 second, first particle and second particle, and then at 1 second, this particle will go here and this particle will go there. So this is one wavelength. Understand? This is one wavelength. From this node to this node is one wavelength. Okay, from node to node, node to the second node is half wavelength. And then from empty node to empty node is half wavelength. And then from node to empty node is what? Node to empty node is 1/4 wavelength. Understand, class?
Yes, sir.
1/4 wavelength. Okay, so this is what we learned in the standing wave. Yeah, we already learned the standing wave equation, 2a cos kx and omega t. So now we are application of this standing wave. In this application, we call it sound wave lah. So we are using the same thing. Yeah, so using the same knowledge, nothing extra. Very simple. Actually, it's a fun. You should think this is a fun thing. Yeah, don't be frightened by many words here. Many. Actually, it's just drawing. You can understand the pattern. That's enough. You see? Okay, so just now I said from node to node is how many wavelength? From node to node, half wavelength. That's why I write as half wavelength. So the whole length L. This is length is the length of string. Is actually half wavelength, correct or not? Half wavelength. So then we can find the wavelength. Wavelength is equal to 2L. Yeah, 2 multiplied L. Lambda equal to 2L. And then we can find frequency of sound produced by this vibration of this string. Frequency of sound. Frequency of, or can say frequency of the string first. Frequency of the string. It is equal to speed of wave in the string. Speed of wave in the string divided by, this is V equal to F lambda lah. V equal to F lambda. And then want to find F is V over lambda. Okay. And then lambda just now you get 2L, right? Because of this lambda equal to 2L. So this is the formula for V over 2L is the formula for F. Understand? For the frequency of vibration of this string. So this is the formula of F equal to V over 2L is the formula to calculate the frequency of this string. Frequency of this string vibrate at this, we call it fundamental mode. Or we can say this is the frequency of the fundamental mode. The mode is put as fundamental mode lah, or F lah. Okay? Okay, harmonic later on, yeah? Harmonic later on. Okay, next. Go to the next one. How to go to the next one? What can you see when I go to the next one? What's the difference? You tell me. Instead of I tell you, you tell me. How to go to the next one? Huh? How to go to the next one? What's the difference in the diagram?
wavelength.
How many wavelength? You add how many wavelength?
2.
Huh? Just now is only half wavelength kan? So when go to the next one, you always add another half. Do you see that?
Yes.
Add another half. And then I want to go to the next one. How? How to go to the next one?
Add another half.
Add another half. That's the key. If you look at the other, the other like closed part and open part, also you add half and add another half. You go to open part, also add another half and add another half. Do you see the difference, class?
Yes, sir.
Like you see the string,
Yes,
if you go to the next frequency, you add a half. You add a half here, correct or not? And then you add another, from here go to here, you add another half, correct or not, class? And then for the close part also, if you know the first one, you can know the second and the third one, and the fourth one, fifth one, and so on. If you go to the next one, you add another half, also another half. And then you go to the next one, and the next, this one and this one. What's the difference? Also another half. Correct or not? Open part also.
Yes, sir.
This one go to the next one. You add another half. Correct or not? And then you go to the next one also. You add another half. Okay? Very simple. Everything is very simple. The important thing is you must remember the first one. If you remember the first one, you can generate all the rest. Okay kah? Boleh faham kah?
boleh sir.
Itulah dia ya. Nasib baik 2 tahun lepas saya dah I already draw this. Now this year I just teach. I no need to redraw again ya. Very troublesome ya. So grateful ya. Actually you can just look at my video. Previous video I already talked about this. Yeah. But of course yeah. I like to teach. That's why I teach again. Okay, so important thing is you must know the first one. Yeah, the fundamental mode. If you know the first one, the rest you can generate. You can derive yourself. If you look, okay, how about the closed pipe? Closed pipe is something like this. You know the pipe, the flute is this lah. This is the flute. And closed pipe, I don't know what example. Yeah, I should check it out. Got one closed end and one open end. Yeah, open end. Yeah, open end and closed end. Closed end, yeah, that's why closed pipe is called as open at one end. Open at one end. Open pipe means both end open. You see that? Both end open. Open at two ends. Closed pipe open at one end. Okay, class?
Okay sir.
Okay, look at here. I want you look at closed pipe first. Actually, later I go to this one because you know I don't like to follow. This one cannot see the whole picture. Yeah, but once I finish discuss this, I will go back to the PowerPoint. Yeah. Then you can understand the PowerPoint better lah. I think you can understand the PowerPoint better after you look at the summary first. Yeah. Okay, because this one is separated, you cannot see the whole picture. This one can explain easily. Yeah. Okay, so closed pipe is open at one end. That means one end is open, the other end is closed. The closed end is just like the fixed end. You know, one end is closed. It's just like, I don't know. I got one example lah. Actually, I got one example. I don't know. You play the. You do this experiment before or not? Yeah. Yeah. People play. You know, got a cup of water. You know, use a cup of water. A cup of water. Maybe do you play the champagne before? You know, champagne before. You know, class. Do you never drink champagne lah? Okay, you never drink champagne. Okay, sorry. So you know, filled with water. Do you see this cup before? A very beautiful glass cup. Glass. If do you know it can produce sound? It can produce beautiful sound. You put different level. You know. You sometimes you put you know, someone Okay, let me copy and paste this again. So effective. You see, Mr. Peck is so effective. You know, maybe you know, full cannot produce anything. Yeah. Full, or maybe you know, maybe no water. Maybe less water. So okay. Maybe like that. Yeah. So let me show. So maybe it's less water, right? You can hear different sound, isn't it? You can hear different sound. You know why? Because got standing wave is produced. Standing wave is produced in the you know, got standing wave produced in the cup. Got standing wave produced. Yeah. So the air particle is vibrate. Yeah, like different length got different sound. Yeah, got different sound. If you this part is anti-note, this part is note. This is a closed pipe lah. This is a closed pipe. Understand? Do you hear before people make a performance using the glass of water?
Yes, sir.
With different water level. This is a closed pipe concept. So the point, this is the closed end. This is the closed end, and this is the open end. This is the open end. So the closed end, the air particle cannot vibrate. Cannot vibrate. So it become the note. Yeah, become the note. And the open end, it become the anti-note because the air particle can vibrate easily. I actually here got animation lah. See that? See that? This is the closed pipe. This two is the closed pipe, and this is the open pipe. Open pipe. You see the closed pipe? This part is the air particle vibrate at all? You see the particle here? Is it vibrate at all?
No.
No. So it become note. No. It become note. This open end, closed end become note. Open end become anti-note because it vibrate at the highest amplitude. 2A. 2A kan. Here, this one is closed. Closed become, the particle become cannot vibrate. Just like last time, the you know, the string lah. Just like the fixed end. Fixed end cannot vibrate, become note. The point you fret also become note. The other part can vibrate because they are not fixed. Yeah, like this one. You see this one? This one vibrate at maximum amplitude. Maximum amplitude. Okay, maximum amplitude. Because you know, they can vibrate freely. This part become note. And then open pipe. This is open pipe because open at both end. So this one can vibrate. This one also can vibrate. So both end become anti-note. Understand? Anti-note. So if I want to draw the diagram, the closed pipe here is like this. Like this. I draw like this. Note, anti-note. This one I want to draw. I draw like this. This one is note. This one is anti-note. Understand? This is a closed pipe. And then how about this one? This one anti-note kan? Anti-note, so it can form like this lah. Anti-note. This is a anti-note. And this part also anti-note. So you must have a note at the middle. Okay, class, I want to ask you again. Class, I want to ask you, how many wavelength is from note to anti-note? How many wavelength? Huh? How many wavelength is node to antinode?
Quarter.
1/4. Betul. Bijak pandai. Cendekiawan semua. Ya? So, yes. It's a 1/4 wavelength. Yeah? This one also the same lah. This one also the same. 1/4. Yeah, 1/4 also. How about this one? Antinode to antinode? How many wavelength? Antinode to antinode?
Half.
Half. Half. So, this is half wavelength. Ya, kalau dari sini ke sini, node ke antinode ke node is 1/4 kan? So 1/4 plus 1/4 is half wavelength. Pandailah pelajar kelas ini. So bagus. So itulah kita selesai sudah chapter ini. Bukanlah. I mean, that's the basic. You got the basic already. So I actually already taught you this one just now. Yeah, in the using this animation, I already taught you the yang fundamental mode for both the closed pipe and open pipe. Understand, class? I already taught you these two. See that? Closed pipe is 1/4 wavelength lah. You see, L is the length of pipe. Ya, dulu kalau string is the length of string lah. Kalau if the string is length of string, if pipe is length of pipe. Okay, length of pipe. So this length of pipe is 1/4 wavelength. 1/4 wavelength. So nak cari wavelength is 4L. 4 times the length of pipe. 4L. And then find frequency of the sound. Frequency of sound or frequency of the air particle. Okay, is V over lambda. Atau V equal to F lambda. So F equal to V over lambda. So lambda inilah 4L. Gantikan lah. So this is the formula. F equal to V over F4L. Yeah? F equal to V over 4L. That's for closed pipe. Understand? Closed pipe formula frequency. And then for open pipe, let's look at the open pipe. Open pipe, tadi cakap antinode to antinode is half lambda, right? Half lambda. Half lambda. So L is the length of pipe. So lambda is 2L. Lambda is 2L. So F equal to V over lambda. So lambda equal to 2L. You substitute lambda equal to 2L. So you get F equal to V over 2L. Okay, class? So we have finished the fundamental mode. We have finished the fundamental mode for these three things: string, open pipe, and closed pipe. So actually, basically, this subtopic, application of standing wave, is these three things only: string, closed pipe, and open pipe. And then you need to derive the rest. Okay? So we have done the fundamental mode. That's the most fundamental. Every other thing is based on this fundamental. Okay? So let's go on to the next one. Okay? Let's go on to the next one. What's the time now? Oh, time's up. Oh, time's up. Okay. Okay. So I think that's all for this lecture. So I will continue teaching you the rest. So for the next class lah. Okay. All right, class. So next class I will continue until at least now you already know why is it node and why is it antinode. Yeah, the like string. Why is it you have two node? You have two node because one point is you fret the point you press down the string. The other point is you already fixed at the guitar. So that's why you got two node. And then closed pipe because one end is closed, so it's the air particle. The air particle cannot vibrate, so it become node. And the other end is open end, so it can vibrate at antinode. Okay, and somehow you already know how to know how many wavelength is this. Node to node is half wavelength. Node to antinode is 1/4 wavelength, and antinode to antinode is half wavelength. That's the most important. And then you can make the formula. I think I've achieved a lot. We have achieved a lot today, and we already know that all these things are standing wave. All these are standing wave, which is related to what you learned before. Like this one, standing wave, got node and antinode. Okay? And it is also related to this formula. this formula, y equal to 2a cos kx sin omega t. So what I think is we have achieved a lot, yeah, for today. And how is it formed? Yeah, standing wave is formed because it is a superposition of two waves moving in opposite direction. Why got two waves moving in opposite direction? Like for the guitar, because you plug, let's say you plug at the center, so it sends two waves to the other end, so they get reflected and superpose each other. So these two waves actually they are identical wave, yeah, because they originate from the same source. They originate from the same source. So these two waves are identical, same amplitude, same wavelength, same frequency, but they are opposite direction. Opposite direction superposed to become a standing wave. Standing wave that we hear in the guitar or violin or flute or what. Flute also, flute. Why flute can produce standing wave? Because you blow at one end, isn't it? This is a closed pipe. This is a closed pipe, right? If you want to produce sound, in a closed pipe, you also, you must have air movement in the, must blow the surface. You must blow the surface. Just like you struck the string. You must struck the string first, kan? You must strum the string first, then only got produce the wave. So for closed pipe also you must blow the end. For open pipe also must blow at one end. For open, but flute got open end, open end. You blow at one end, so it start to vibrate. You know how is standing wave produced in the closed pipe? Because when you blow at one end, so the wave will, when you blow, let's say you blow here, you're sending wave. You're sending wave to the what? To the water. What is this? You are sending wave. You are sending wave to the close end. So the close end, so it will reflect. You will reflect back. You will reflect back. Then it will reflect back. No, you reflect back. You reflect back. So these two wave, they will superposition, and produce what? Standing wave. Understand? So you must blow first. You must blow because this is a disturbance. Disturbance to produce what? Progressive wave. First you must have progressive wave, kan? You must have progressive wave. You blow and then get here. You get reflected. Here you get reflected. Wow! Suddenly it changed color. Yeah. So you get reflected. And then they superpose, produce standing wave. So standing wave actually is come from progressive wave, and progressive wave come from disturbance. So you must have disturbance first. So if you want to make the flute sound, you must blow. If you want to make the guitar, you want to make the guitar sound, you must also strum the guitar. You must strum the guitar, right? If you don't strum the guitar, where got sound? If you don't blow the flute, where got? If no disturbance, where got standing wave? Correct or not? Understand, class? Today lesson.
Yes.
That's all for today lah. Okay, thank you very much for listening. I love you all. So see you tomorrow. Okay, see you next time. Okay, bye.
Thank you, sir.
Thank you, sir.